Hello everyone, this is a recorded presentation of a paper titled RNNP, a robust few-shot learning approach that has been accepted into the Winter Conference on Applications of Computer Vision 2021. My name is Pratik Majumdar and I am a PhD student at the Indian Institute of Technology, Kanpur, and my co-authors are Pravinder Singh and Dr. Vinay Nambudri. Learning from a few examples is an important practical aspect of training classifiers. However, the few examples provided may not be correctly labeled. We propose a novel, robust few-shot learning approach to address this issue by generating robust prototypes. Specifically, our method refines the class prototypes by producing hybrid features from the support examples of each class. Our method can replace the evaluation phase of any few-shot learning method that uses a nearest neighbor prototype-based evaluation procedure. In the few-shot learning setting, there are two sets of classes, that is, the base class set and the novel class set. The base classes have many labeled data points, but the novel or the few-shot classes have very few labeled examples. The few-shot learning setting emulates a limited data setup by following an episodic setup. Each episode consists of a set of few support examples per class and a set of query examples. Episodes with n classes and k support examples per class are referred to as n-way k-shot episodes. The model should use the limited support examples available per class in the episode to classify the query examples in the episode. During the novel class evaluation phase, the network receives episodes of the novel classes. In the novel class episodes, some of the support examples may not be correctly labeled. This type of corruption makes the few-shot classification of the novel classes very challenging. The distribution of label corruption is assumed to be uniform across all the classes in each episode, and the objective of the network is to deal with this corruption and classify the query examples in each novel class episode. Our proposed robust nearest neighbor prototype based testing approach improves the robustness of few-shot learning methods when operating on episodes that contain support examples with corrupted labels. Let us assume that we have a base network already trained on the images from the base classes. During the novel class evaluation phase, given a novel class episode, we first extract the features of the support images and the query images using the trained base network. Next, we calculate the prototypes of each class using the support example features of each class. The computation process of the prototypes unknowingly utilizes the support examples with corrupted labels too. Therefore, the class prototypes are not fully correct and required to be refined. In order to refine them, we first create unlabeled hybrid features by combining the support images features from the same class. For each query image, we perform soft k-means clustering on the combined set of support image features, the hybrid features, and the corresponding query image feature. We use the class prototypes computed earlier as the initial cluster centers of the clustering algorithm. Using the current cluster centers, we assign soft labels to the support and hybrid features and the single query feature. We update the cluster centers using these newly obtained soft labels. Since the support features with corrupted labels are relatively closer to the features of the support examples of their actual classes, the clustering process is able to assign them to their actual classes. We repeat this process for a few times and use the final cluster centers as the refined class prototypes. We use the refined prototypes to find the nearest class prototype to the query example in the feature space and predict it to be the class of the query example. Our experimental results show that using our approach reduces the number of incorrectly labeled support examples significantly in each episode. Our results on the mini-imaging dataset show that our method performs significantly better than the base method for both the 5-shot and 10-shot setting for label corruption ranging from 0 to 40%. We get a similar set of results for the tiered imaginary dataset too. Thank you for watching our presentation. It has been a pleasure to present our work here. Thank you.